Alright, Math 3, here we are with graphing cosine. So this is going to be very similar to sine with some slight differences, but the same concepts. So if you understand that, this should come fairly easy as well. So again, we need to look at the way the function goes. So the first thing is the A right here. That's our amplitude. Remember, since this is a periodic function, it's going to look something like this. The amplitude tells us how high we go and how low we go. Okay. Then the K tells us how far up or down we shift the whole graph. And it's called our midline shift. And then the B here is how we find the period. So if you go 2 pi or 360, if you're doing degrees, divided by B, that'll give you what your period is. Okay? And remember, we're basing this off of our unit circle we created. Okay, where we have these points on here, degrees, those special triangle degrees. But really, just like with the sine, with the cosine, we're focused on 5 of those points. With this one being 0 degrees or 0 radians, and 360 or 2 pi. This being 90 or pi halves, 180 or pi, 270 or 3 pi halves. Okay? And the idea with sine, it was the y value. With cosine, cosine is the x value. Okay? Now this is where it gets kind of tricky because that when we're graphing it, this x-axis ends up being the degree or the radian measure. So the 0, 90, 180, 270. We see those down here on the x-axis, okay? Or if we do it in radians. And then the x value of the points here become the y value on the graph. So the 1, 2, 3, negative 1, negative 2, negative 3. So with cosine, we start out here, and this is a 1 for the x value. Then as we travel to 90 degrees, it goes to 0. Then as we travel negative 1, back to 0, and then back up to 1. Whereas with the sine, right, we started at 0, then went to 1, then back to 0, to negative 1, and then finally back to 0. So with the sine, our parent graph looked, with those 5 important points, looked like this. Okay? Whereas our cosine is going to give us a different shape. But with that period only being 1 revolution around the circle, so we could just keep going around and around, and that's why we keep doing the pattern. Okay? Because it's like we're going around and around on that circle. So let's take a look at what it'll look like for the parent graph. Yeah. So let's take a look at the parent graph. So for cosine, our amplitude, because there's no number out there, it's 1. And our period, because there's no number here, is 2 pi. And our k we could say is 0. And that's true for both 1 and 2. So this will count for both. Okay? So our amplitude being 1 and our k being 0, that means our midline is right here on the x-axis. Okay? Whether it's in radians or degrees, same thing. So we're going to start up at 1. Okay? And because our period's 2 pi, we're going to end up, or 360, we're going to end up at 1. Okay? Right? Looking back at this, we start at 1. And then after we go around, that's also where we end. Okay? So starting at 1, go around, end at 1. Okay? And then at negative 1, that's when we're halfway around the circle. So in our graph, that's the halfway point. So halfway would be 180. So we go down to negative 1. Okay? Then, thinking back to this circle, we get up to 0 when we go to 90 and 270. So here, at 90 and 270, we're at 0. So it looks like we want to do kind of like a quadratic, but we can't. We got to remember this is periodic. It's going like this. So it's actually going to look more like that. Okay? And the same thing in radians. We start at 1 at 0, 2 pi at 1, pi down to -1, pi halves at 0, 3 pi halves at 0. And we get our graph like that. Now, just to remind you, the sine function looks like this. Okay? So they're kind of similar, but basically shifted a bit. So the cosine looks a little bit different. So let's first start off and see what that amplitude does to it. Okay? So remember, amplitude affects how high up or how far down it goes. So if we have our parent graph, like that, so an amplitude of 2, still a period of 2 pi, means instead of starting at 1, we start at 2. Instead of ending at 1, we end at 2. And instead of going down -1 halfway, we go down -2. Now 90 and 270 still stay in that same spot. And it looks like that. If it's 1/2, looking at our parent graph, okay, at 1/2, we just cut it down a half, down a half, down a half, but 90 and 270 still on the 0, and it just looks like we squished it. Okay, it doesn't matter if it's degree or radians, same idea. Okay, amplitude of 4, period of 2 pi. This one had 2 and 2 pi. Okay, so instead of starting at 1, we start up at 4. And at pi halves, we're at 0. At pi, we're down to -4. 3 pi halves, we're at 0. And 2 pi, we go back up to +4. So it looks like that. Okay. Again, our parent graph would look like this. So with an amplitude of 2, we just bump it up, bump it down. And then these guys on the midline stay the same. Okay. So again, that halfway point, normally it looks like this. So we just go halfway, halfway, halfway. But these stay the same. It ends up looking that way. Alright, now let's take a look at how the period gets affected by multiplying or dividing. Okay, just like with the sine, if you're dividing, you're going to end up having a bigger period. If you're multiplying, you end up with a smaller one. So let's take a look at 9 and 10 to kind of show this. So amplitudes of 1. Periods, though, so I'd go 2 pi divided by, and that's like 1/2. Okay, which would be 2 pi divided by 1/2, but we can't do that, so we can times by the reciprocal. So 2 pi times 2 would give us 4 pi. And this one at 2, that's like 2 pi divided by 2. Those would cancel, and our period would just be pi. So, if we have our parent function here, 0, 1, at 90, or pi halves. At pi, it's down below, so it's going to look like that. And that same parent graph on this other scale would look like this. Okay. So same parent graph, but we had to have two different scales because our periods are so different. Okay. But we start the same amplitude of 1, so I'm starting in the same place. But we also end at 4 pi. So we pulled it out longer. So now, this pi that goes below is halfway between the first and the last. So halfway between the first and the last, at 2 pi, I go down 1. Okay. Then, the 90, or, pi halves, that hits the 0 in between 0 and pi. So in between these two, at pi, is when I hit 0. Same way with the other part of it. Halfway between, I hit that midline. So at 3 pi, I hit the midline. We can see that we've just kind of pulled it out that way. Whereas if I look at 10, we're actually going to push it in. So I start same place, but this time I end at pi instead of 2 pi, so we've squished it in. Then halfway between at pi halves, I go below. And then halfway between here and here, when we're hitting our midline, so at pi fourths and 3 pi fourths. We end up with that. Okay, so we can kind of see how that affects things. So looking up at number 8, okay, our parent graph would look like this. So amplitude of 1, period of 2 pi divided by 1/3, which is basically 2 pi times 3, so 6 pi. So I start at 0, 1, and I'm going to end at 6 pi, 1. Halfway between those two at 3 pi, I'm going to drop down 1, because my amplitude is 1. And then halfway between those two, I'm going to hit my midline. So halfway between 0 and 3 pi would be like 1 point pi, so it's like kind of in the middle. Halfway between 3 pi and 6 pi would be in between 4 and 5 pi, so it looks like that. And there's my new one. Okay, number 11 is the last just amplitude, or just period. So amplitude of 1, period of 2 pi divided by 4, because b is 4. 2 pi divided by b simplifies to pi over 2. So period of pi over 2. So my parent graph would look like this. So my graph, start in the same place because amplitude's the same, but now we're going to end at pi halves, so we squish it down really small. Halfway between 0 and pi halves is pi fourths, so I drop down 1 below that, and then in between, and I get that. Okay, now 12, 13, and 14, we're going to look at just how that midline shift works. So cosine, our parent graph, looks like this. Okay, so this plus 2 means our k is going to shift up 2. So normally our midline's right here. Now we're shifting that midline up to 2. Okay, so we don't start here again. Okay, but because that is the same as the amplitude, being that our amplitude is 1, okay, from here I go up 1. So I'm going to start up here at 3. Okay, because I base it off my midline, not off the x-axis. Then our period, because there's nothing here, is still 2 pi. So at 2 pi, I hit that same spot. And then in between these two at pi, from that midline, I go down 1, because that's my amplitude. And then halfway between these two, I'm hitting that midline. So it looks like this, and it's basically that parallel line that we've just pulled upwards. Okay, so that's all there is to it with the midline. So minus 2, we drop it down 2. So that was negative 2. Amplitude of 1 though. Period of 2 pi. So on my graph, I'm going to start above that 2, just 1 though. That's also where I end because my period's 2 pi. Halfway between, I go below. Then halfway, I hit the midline. Halfway, hit the midline. And there's my graph. Okay, it's one same idea, but just shifted to negative 1. So amplitude of 1, period of 2 pi. Start right up here, 1 above the midline, end 1 above the midline. Halfway, I'm 1 below the midline. Then halfway and halfway, I'm on the midline. Alright, so moving through this one a little bit quicker. So if this still seems a little fast, take a look at the sine video if you haven't, and that can help you with some of these ideas. Pray a little bit better. Go a little bit slower in that one. Okay, now these last 4, we are dealing with doing all the changes. Okay, so first off, I'm going to start by making our parent graphs. Okay. You can see just by how I'm doing all these parent graphs slightly different is that our scales are different. So you've got to pay attention to that because the scales can really mess you up if you're not paying attention. Okay, so these are all the same parent graph. Remember, parent graph, amplitude of 1, period of 2 pi, and midline of 0. So let's take a look at 15. So the best thing to do is to start off with your midline. So my midline is negative 2. Okay, so I know that normally where my midline's right here, I'm shifting it down to negative 2. That means that's my new point of reference on how far up or how far down I go. Okay, but I need to know where I start and where I end. Which on this one, actually, the amplitude needs to help you with the start. So my amplitude of 3 tells me instead of only going up 1 point, I'm actually going up 3 to start off. In this case, it happens not to be there. Oh, it does. Okay. And that's also where I end. Okay. But the question is, where am I going to end? Now we need our period. So it's 1/4 theta, or theta divided by 4, which basically, if you divide here, take 2 pi and multiply it. So I end up with a period of 8 pi. So at 8 pi, that's where we're going to be at that same place. Okay. Notice, start and end, always on that same line. Halfway in between, we go that same distance, but down. It's off the midline, not off the x-axis. Then once we've got those 3 points, we find the in-between. So in between 4 and 8 would be 6. So on the midline, there's 6. In between 0 and 4 would be 2. So on the midline is 2. And there's our new graph. Much wider, much deeper. Okay, so that's all there is to it. So 16, our midline, plus 2. So we're bumping our midline up 2. Okay, then to start, our amplitude of 2. So from that midline I go up 2 and I start. But where do I end? So we've got 4, so I go 2 pi divided by 4, which becomes period of pi halves. So we end also at pi halves. Halfway in between that, we go 2 below our midline, so pi fourths. Then halfway in between each of those, we're hitting the midline, and there's our new graph. All right, 2 more to go. Okay, so again, that midline, negative 1, dropping down our midline by 1. Okay, then our amplitude of 3. So going up from my midline, 3. There's where I start. How do I end it? Period of, so divided by 4, so basically 2 pi times 4, so 8 pi again. Another stretched out, so we go 3 up from the midline at 8 pi. And halfway in between there, 4 pi. From our midline, we go 3 down. Then on the midline is halfway in between the start and the middle. So at 2 pi, we're on our midline. Halfway between middle and end. So 6 pi, we're on our midline. And we get our graph. Alright, last one. Same process. Midline of 2. Bump it up to 2. And I draw that midline because it's a good visual reminder of where you're now starting from. Okay. Our amplitude is 1/2. So I'm only going to jump up 1/2 of that. Okay, so now where do I end? Well, it's a 4, so 2 pi divided by 4 gives us pi halves. So I end at pi halves. Okay. Then we find that middle which would be pi fourths, and I'm going to go down 1/2. Then in between those, the first and the last part, I draw my midline points, and there's my little itty-bitty graph compared to the starting point. Alright, so there's cosine. Remember our function, you need to know how the amplitude affects it, how the b can turn into the period, and how the midline affects things. Remember, this is all based off that unit circle. And there we go, guys.